Hello, welcome back. As we said, before establishing the connection between information systems and the concepts we have just introduced, that is, business processes, sub-processes and activities, business functions, and individual business transactions, we will illustrate them using the same car garage analogy. In our new garage, however, the warehouse manager, the database management system, will manage not just the spare parts, but also the cars themselves. Whenever a customer walks into a garage, he or she will hand the car keys over to the warehouse manager. In a way, we can think of the car just as the sum of all the auto parts it contains. The mechanics from the various specialties involved will come, take the car, complete the specialized operations, and then hand the car back to the warehouse manager until the next mechanic from a different specialty comes around. The basic elements from the analogy are still the same. The application programs are the mechanics. The car parts are the data, and the warehouse manager is the database management system. Hopefully, you will be able to intuitively identify the equivalences in this analogy for the concepts discussed in these videos. May I suggest that you pause the video for a few seconds and try to figure out what business processes, sub-processes and activities, business functions, and open and close individual business transactions might relate to in the analogy? If needed, you might want to review the definitions from the transcript or by rewinding the video. Give it a try. Well, I hope you found this exercise of mapping your mental image of these concepts to the analogy interesting, and that it helped you to think about them afresh. Yes, the business process would be the series of related activities required to carry out a given type of maintenance, such as the scheduled 10,000 miles maintenance or the activities involved in fixing a broken automatic gearbox. Each process can be broken down into smaller sub-processes. For example, the scheduled 10,000 miles maintenance can be subdivided into replacing and refilling fluids, reviewing the braking system, and so on. Each business function, such as accounting or manufacturing, would correspond to specialization, such as suspensions, steering, or electronic ignition. Each car, or rather, the maintenance order associated with each car, would correspond to the individual business transactions. Unfinished cars would correspond to open transactions. Let us now move on to information systems. We have already said that management information systems support the information requirements and information flows of the corresponding business processes. Now, what does that mean in practice? Let us take the example of the order fulfillment business process and look at an individual business transaction, a given customer order, going through that process. For each business activity included in the process, such as logging the order, checking the credit limit, and so on, and for each individual transaction going through the process, the supporting management information system has to carry out the associated information processing activity. Sometimes the business activity required by the business process and the information processing activity carried out by the information system are the same. For example, while logging a customer order. Other times, the business activity takes place in the physical or human world, such as physically manufacturing or shipping a given product, or taking a subjective decision on extending a credit limit. Even in these cases, the information system will monitor, record, and sometimes trigger the activity. In the traditional pre-ERP approach to information systems, each management information system would be specialized in one function. It would encompass a specialized set of programs, for example in accounting, and the corresponding data structure implemented in a database accessed through a database management system. Thus, a company would have a sales package, a financial package, a warehousing package, and so on. They would be the equivalent of specialized repair shops, focusing solely on, say, tires or gearboxes. In our garage analogy, these specialized repair shops are fine if all the maintenance operations customers must perform are confined to a single specialty, such as replacing the tires. If, however, we need to carry out an operation involving several specialties, such as the scheduled 10,000 miles maintenance, this becomes cumbersome for the customer. The customer would have to take the car to several different repair shops and coordinate it among themselves. Similarly, in the business world, the most important business processes are multifunctional, in the sense that they traverse various business functions, departments, or specialties. In the order fulfillment example, after an order is logged, its creditworthiness must be approved. The availability of the requested item in inventory must be verified in order to issue purchasing or manufacturing orders for missing elements, and so on. Each of these activities corresponds to different functions or departments. However, each activity requires, as an input, the data on the individual transaction and the result of the previous activities. Thus, if a company has separate management information systems for each function or department, it must keep on extracting data from each information system regarding the individual transactions on which it has carried out an activity and sending it as an input to the information system in charge of the next activity. For example, the sales admin system in charge of logging customer orders will have to send all these orders to the inventory management system to check availability, and so on. The obvious solution is to have an integrated management information system that can support multifunctional business processes, analogously to a full-service garage that can carry out any maintenance operation even if it involves several specialties. The integrated information systems, known as ERPs, were designed to address that need. In the next video, we will discuss how they do it. How do they handle the explosion in complexity that this implies, and which is the role of the central integrated database in this approach? Thank you. I will see you there.